Good morning, everybody. This is Khaled Youssef, a professor in the Department of Architecture Engineering at Asyut University, Egypt. First, I'd like to start with thanking Dr. Ahmed Ashri and the organizing committee for having me here. The lecture I will give today is titled Intelligence Meets Buildings. In fact, the presentation consists of four sections. In the first section, I will talk about the definitions of human intelligence, the theories of human intelligence, and the measures or how to measure human intelligence. In section 2 of the presentation, I will talk about intelligent buildings, the definitions of intelligent buildings, different perspectives to intelligent buildings, and finally, the main features and key performance indicators or the KPIs of intelligent buildings. In part 3, I will talk about the structure of intelligent buildings, while in the last section of the presentation, I will give some examples for intelligent buildings. So let's start with the concept of human intelligence, its definitions, theories, and measures. In fact, I would like to start this section with a question. Is there a unified or standard definition of human intelligence? The answer is no. According to a research paper conducted by Legg and Hatter in 2006, there are 71 definitions of human intelligence. These include the capacity to acquire and apply knowledge, as per the American Heritage Dictionary, the abilities to solve problems and adaptation to new situations, according to Old World's Dictionary, and adapting effectively to the environment, as per Encyclopedia Britannica, which argued that intelligence is not a single mental process. It is a combination of many mental processes. Further, intelligence means solving problems with cultural settings, according to Gardner. By the end of the paper, Legg and Hatter added their own definition of human intelligence. Therefore, the number of definitions increased from 71 to 72. Their definition of human intelligence was the agent's ability to achieve goals in a wide range of environments. A number of human intelligence theories has been developed. At the top of these theories comes the theory of multiple intelligence developed by Gardner in 1983. According to Gardner, intelligence can be classified into linguistic intelligence, logical mathematical intelligence, spatial intelligence, musical intelligence, bodily kinesthetic intelligence, interpersonal intelligence, and intrapersonal intelligence. Later, another type of intelligence was added, which is the naturalistic intelligence. According to the theory of successful intelligence developed by Sternberg in 1985, intelligence can be classified into three main categories. These categories are analytical intelligence, which means the ability to analyze, creative intelligence, which means innovative solutions, especially when confronted with challenges, and practical intelligence, meaning the adaptation to the environment. Past theory of intelligence is developed also by Laurier in 1966. The theory is getting its name from the first letter of the four words planning, attention, simultaneous processing, and successive processing. As per Laurier, these functions are proposed in four main areas of the brain. Now, the big question is how to measure human intelligence. To measure human intelligence, the IQ test is developed. IQ means intelligent quotient. The test is developed based on the concept of the G factor or the general intelligence factor. And this implies having broad abilities of intelligence such as short-term memory or GSM, long-term storage, which is GLR, visual processing, fluid intelligence, processing speed, etc. Upon completion of the IQ test, the IQ score is calculated. Following the normal distribution curve, or the so-called bell curve, it's also found that 68% of the test takers got a score between 85 and 115 to be classified average. People having an IQ score from 115 to 129 are classified above average, while people having an IQ score from 160 to 175 are classified extraordinary genius. Now, it is a time to talk about intelligence in relation to architecture. Here, I will introduce some definitions of intelligent buildings, how to measure intelligence in relation to architecture, the keywords to identify intelligent buildings, and finally, the key performance indicators or the KPIs of intelligent buildings. I will start here by asking a question similar to the one I started my lecture with. Is there a unified or standard definition of intelligent buildings? The answer again is no. Architects, researchers, and architecture institutions define different perspectives to architecture intelligence. In the United States, as an example, intelligent buildings are productive and cost efficient buildings. This can be achieved by the optimization of the structure, building systems, services, and the management system. In Europe, the intelligent building, or the definition of the intelligent buildings, or according to the European Intelligent Building Group, the concept of IBs or intelligent buildings is more concerned with occupants, efficient management of resources, and minimum life cycle cost. In Singapore, intelligent buildings have or should have automatic control systems, good network infrastructure, and telecommunication facilities. In China, intelligent buildings should have 5 A's. These include communication automation, or the CA, office automation, or the OA, building management automation, which is the BA, fire automation systems, FA, and maintenance automation systems, which is MA. So it's all about automation. In Japan, the concept of intelligence in relation to architecture is more concerned about Japanese culture and the climate in terms of management efficiency, satisfaction of occupants, lower cost, and flexibility. This section of the presentation is very important as we came to how to measure intelligence in relation to architecture. According to the Asian Institute of Intelligent Buildings, or the so-called AIIB, an intelligent building is designed based on quality environmental modules to achieve a long-term building value. These modules are green, or M1, space, or M2, comfort, M3, working efficiency, M4, culture, M5, high-tech image, M6, safety and structure, M7, management practice and security, M8, life cycle cost, M9, and health and sanitation, M10. Each module has a number of elements or assessment criteria questions. As an example, M1, or the green features, has 75 elements transformed into 75 assessment criteria questions. The total number of elements or questions is 378 questions or elements. As an example, module number 7, which is titled Safety and Structure, has 31 elements, including earthquake monitoring devices, wind load monitoring devices, structural devices, structure control, attack considerations, etc. The Asian Institute of Intelligent Buildings, or the AIIB, assigned a relative weight for each module according to the building type. As an example, for commercial buildings or office buildings, the relative weight of M1 is 7 and the relative weight of M2 is 8.5. In hospitals, the relative weight of M1 is 7 and the relative weight of M2 is 5, etc. According to the total score achieved, the building can be ranked. As an example, if the IBI score is between 80 and 100, the ranking would be Class A, and the building will be a distinction building. If the score is between 35 and 49.9, the ranking is D, and the building is a fair building. Summing up, and based on the definitions of intelligent buildings and the wide spectrum of approaches developed, the following 24 benefits or keywords are somehow interrelated with intelligent buildings. These include user satisfaction, comfort, best utilization of space, life cycle cost, productivity, interaction, etc. The previously mentioned benefits can be categorized into four main categories or KPIs. Uh, these KPIs are KPI number one, smartness, KPI number two is economic and cost efficiency, KPI number three is concerned with social sensitivity, and KPI number four is about the environment. Um, this part of the presentation is focusing on the analogy or similarity between buildings and human beings concerning intelligence and the main concept of intelligent building systems. For a human being to be termed intelligent, he or she should have a wide spectrum of abilities, including interpersonal abilities, visual or spatial abilities, linguistic abilities, etc. On the other side, for a building or a system to be termed intelligent, it should be concerned, connected to other systems or buildings. It should acquire self-recognition abilities. It should have the ability to do logical or mathematical operations, etc. This figure shows how strong the relationship between the human intelligence and the building intelligence is. As an example, the logical or mathematical abilities of people are translated into cabling solutions, integrated control systems, communication technologies, and building automation systems. Another example, the interpersonal abilities of intelligent people can be also transformed into user interfaces and sensors in intelligent buildings. In other words, intelligent buildings can self know, self decide, and self respond to changes, similar to intelligent persons, by using different tools. Sensors enable buildings to self know, controlled systems enable buildings to self decide, and kinetic systems enable building self respond. In this part, which is the last section of the presentation, I will talk about two cases of intelligent buildings. These are two International Finance Center in Hong Kong and the Edge Building in Amsterdam. The International Finance Center is one of the top 20 tallest buildings in the world. The development area is about 186,000 square meters. The building has 88 floors. It is about 420-meter height. The project has won a lot of awards for its innovation and outstanding design, technology, and construction. As for the structure of the building, it has a central concrete wall plus 8 external columns. This maximizes the view from the tower. First, the structure system allows the building to withstand high wind speed up to 230 kilometers per hour. As for the fire and life safety systems, 4 horizontal fire separation floors are provided. 2 fully fire protected lifts are provided also. These are called firemen lifts. Features of intelligence and smart systems in this building include also the security systems, smart card access control, face recognition access control, X-ray checking machines, and car parking security. The Asian Institute of Intelligent Buildings, or the AIIB, evaluated this building through the evaluation of the 10 quality environmental modules developed by the Institute from M1 to M10. The IBI score of this building was 95.06 out of 100, which means that this building is a distinction building. Another example is the Edge building in Amsterdam. It is a 40,000 square meter office building. The building has the highest BREEAM rating score of about 98% to be classified outstanding building. The building offers its employees collaborative working environments, socialization opportunities, comfort, and productivity. Most important is the use of sustainable technologies. Features of intelligence are strongly correlated with sustainability in this building. These features include, but not limited to, 70% less electricity compared to other office buildings, a largest array of photovoltaic panels on the rooftop, continuously measured occupancy, movement, lighting levels, humidity, and temperature with about 3,000 sensors in the building installed in the buildings. Employees are connected to the building all the time via an app on their smartphones. That is how the building knows where every employee in the building is, offering him or her customized services when needed. The features of building intelligence in this building include a smart shading system to minimize heat gain, transparent walls to maximize external views, a collection of rainwater to be used afterwards to flush toilets and irrigate gardens, LED lighting systems developed by Philips to reduce the energy requirement by almost 50%, and customized temperature and light levels. So it was not a surprise that the Edge building achieved a number of awards, including BREEAM Award in 2016, British Expertise International Award in 2016, as well as an Outstanding International Architecture Project, Best Sustainable Design category in 2015, Sustainable Building Award in 2015, and Best Innovative Green Building in 2015. Thank you for your attention. I hope you enjoy the lecture as well as the presentation. If you have any question, please contact me via email, WhatsApp, or phone call. Thank you again, and goodbye.